Welcome to MindTier Learning, where we make GCSE learning simple. If you find this content helpful, please remember to like the video and subscribe to our channel. It really helps us reach more people and bring you even better content. Thanks for your support. Welcome to today's lesson on the causes and impacts of flooding. In this lesson, we are going to look at why rivers overflow, why some places are more at risk of flooding than others, and what happens when floods affect people, businesses, infrastructure, and the environment. Flooding is one of the most important topics in GCSE Geography because it links together physical geography, human geography, climate change, urbanization, land use, and decision-making. By the end of the lesson, you should understand that flooding is rarely caused by just one thing. It usually happens because several factors combine. Some of these factors are natural, such as heavy rainfall, steep slopes, or impermeable rock. Others are caused by humans, such as urbanization, deforestation, and building on floodplains. We will also look at the consequences of flooding, both for people and for the natural environment. Let's start with our learning objectives. By the end of this lesson, you should be able to do 4 things. First, you should be able to distinguish between human and physical causes of flooding. That means you need to know which causes are natural and which causes are linked to human activity. Second, you should be able to explain how land use changes affect river hydrographs. A hydrograph shows how a river responds to rainfall, so we will look carefully at how urbanization and deforestation can change the speed at which water reaches a river. Third, you should be able to evaluate the socioeconomic impacts of flooding on local communities. Socioeconomic means the effects on people, society, and money. For example, homes may be damaged, people may be displaced, businesses may close, and repairs may cost millions or even billions of pounds. Finally, you should be able to assess the environmental consequences of high-flow events. A high-flow event means a time when a river has much more water than usual. This can damage habitats, spread pollution, but sometimes also bring benefits such as depositing fertile alluvium. So, throughout the lesson, keep thinking about this key question. Why do floods happen, and why do they matter? Before we look at why rivers flood, we need to quickly recap the lower course of a river. The lower course is the section near the end of a river's journey, close to where it reaches the sea or a lake. By this point, the river is usually wider, deeper, and carrying a large amount of water and sediment. There are 3 important landforms to remember. The first is the floodplain. A floodplain is the flat land on either side of a river. It is made from layers of alluvium, which is fine sediment deposited when the river floods. Floodplains are naturally at risk of flooding because they are the area a river spreads onto when it has too much water. The second feature is a levee. A levee is a natural embankment found beside the river channel. Levees form when a river floods and deposits heavier sediment close to the channel. Over repeated floods, these deposits build up into raised banks. The third feature is a delta. A delta forms at the mouth of a river, where the river slows down as it enters the sea or a lake. Because the river loses energy, it deposits sediment. Over time, this sediment builds outwards and can create new land. These features are important because they remind us that flooding is not unusual for a river. In fact, rivers naturally flood their floodplains. The problem comes when people build homes, roads, farms, and businesses in areas that rivers naturally need during times of high flow. Let's do a quick check. The question is, which of these features is formed by the natural sorting of coarse sediment during repeated flooding? Is it meanders, levees, deltas, waterfalls? Take a few seconds to think about your answer. Remember, the question is asking about a feature created by repeated flooding and the sorting of coarse sediment. Coarse sediment means larger, heavier material, which is dropped first when floodwater loses energy. The correct answer is levees. Levees form when a river floods and spills over its banks. As the water leaves the river channel, it quickly loses energy. The largest and heaviest sediment is deposited first, close to the river channel. Over many flood events, this builds up into raised banks called levees. Meanders are bends in the river. Deltas form at the river mouth. Waterfalls are usually found in the upper course where there is a sudden drop in the riverbed. So the key idea is this. Levees are built up by repeated flooding and sediment deposition. Now we need to cover some essential vocabulary. The first key word is hydrograph. A hydrograph is a graph that shows river discharge over time, usually after a storm. Discharge means the amount of water flowing in a river at a particular point. It is usually measured in cubic meters per second. The second key phrase is lag time. Lag time is the delay between peak rainfall and peak discharge. In other words, it is the time between the heaviest rainfall and the moment when the river reaches its highest flow. This is really important for flooding. A short lag time means water reaches the river quickly, which can increase flood risk. A longer lag time means water reaches the river more slowly, giving the river more time to cope. The third word is impermeable. Impermeable surfaces do not allow water to pass through them. Concrete, tarmac, and some types of rock are impermeable. If water cannot soak into the ground, it flows over the surface instead. This is called surface runoff. The fourth word is urbanization. Urbanization is the process of an area becoming more built up. This usually means more houses, roads, pavements, car parks, shops, and drainage systems. These words are central to today's lesson, especially hydrograph, lag time, impermeable, and urbanization. Let's think about flooding using a simple example. Imagine a bucket with a small hole at the bottom. If you pour a small cup of water into the bucket every minute, the water may drain out through the hole before the bucket fills up. The system can cope. But what happens if you suddenly pour a whole gallon of water into the bucket at once? The water enters faster than it can drain away, so the bucket fills up and overflows. A river works in a similar way. A river channel has a certain capacity. That means it can only hold and carry a certain amount of water at once. If rainfall enters the river system slowly, the river may cope. But if water reaches the river very quickly, or if there is simply too much water, the river channel may not be able to carry it all. Flooding happens when the input of water is greater than the river channel's capacity. This can happen because of intense rainfall, saturated ground, impermeable surfaces, steep slopes, blocked drains, or because humans have changed the landscape. So flooding is not just about how much rain falls. It is also about how quickly that water reaches the river. Now let's look at the physical causes of flooding. Physical causes are natural factors. They are not directly caused by humans. The first physical cause is precipitation. Heavy or prolonged rainfall can increase the amount of water entering a river. If rain falls faster than the ground can absorb it, surface runoff increases and more water quickly reaches the river. Intense storms are especially dangerous because they can overwhelm drainage systems and river channels in a short period of time. The second physical factor is geology. Geology means the type of rock underneath the ground. Some rocks are permeable, meaning water can pass through them. Others are impermeable, meaning water cannot easily pass through. If an area has impermeable rock, less water infiltrates into the ground and more water flows over the surface into rivers. This increases flood risk. The third factor is relief. Relief means the shape and steepness of the land. On steep slopes, water runs downhill quickly. This creates rapid surface runoff and reduces lag time. In flatter areas, water usually moves more slowly, so the flood risk may be lower. Another very important factor is antecedent moisture. This means how wet the ground was before the rainfall event. If the ground is already saturated from previous rain, it cannot absorb much more water. So when another storm arrives, more rainfall becomes surface runoff and rivers rise quickly. So the key physical causes are heavy rainfall, impermeable geology, steep slopes, and already saturated ground. Now let's move on to human causes of flooding. One of the most important human causes is urbanization. When an area becomes urbanized, natural surfaces such as soil, grass, and woodland are replaced with impermeable surfaces such as concrete, tarmac, roofs, roads, and pavements. This matters because natural ground allows some rainfall to infiltrate into the soil. But concrete and tarmac do not let water soak in. Instead, rainwater flows across the surface. Urban areas also have drainage systems such as gutters, drains, and sewers. These are designed to remove water from streets quickly, which is useful for stopping roads from becoming waterlogged. However, this water is often sent directly into rivers or streams. That means urbanization can speed up the movement of water into the river channel. The result is usually a shorter lag time and a higher peak discharge. In simple terms, the river rises faster and reaches a higher level, which increases the risk of flooding. This is why urban planning is so important. If towns and cities are built without enough green spaces, flood storage areas, or sustainable drainage, the risk of flooding can become much worse. Another important human cause is deforestation. Deforestation means removing trees from an area. This can happen for farming, housing, roads, logging, or other forms of development. Trees help reduce flood risk in several ways. First, they provide interception. This means leaves and branches catch some rainfall before it reaches the ground. Some of this water may later evaporate back into the atmosphere. Second, trees support evapotranspiration. This is when water is transferred from the land and plants back into the air. Third, tree roots help improve the soil structure. Roots create spaces in the soil, allowing more water to infiltrate. This means less water runs straight over the surface. But when trees are removed, these natural processes are reduced. There is less interception, so more rain hits the ground directly. The soil may become compacted or saturated more quickly. Without roots helping infiltration, more water becomes surface runoff. As a result, water reaches the river faster. This means deforestation usually causes a shorter lag time and a higher peak discharge. So the key point is, trees slow the journey of water to the river. Removing them speeds it up. Now let's test that understanding. The statement says, urbanization and deforestation lead to a longer lag time. Is that true or false? Take a moment to think. Remember, lag time is the delay between peak rainfall and peak discharge. So ask yourself, do urbanization and deforestation slow water down, or do they speed water up? Urbanization creates impermeable surfaces and drains that move water quickly to rivers. Deforestation removes trees, reducing interception and infiltration. So what happens to lag time? The statement is false. Urbanization and deforestation do not usually lead to a longer lag time. They usually lead to a shorter lag time. The reason is that both processes speed up the movement of water into rivers. In urban areas, water cannot soak into concrete and tarmac, so it flows over the surface or through drains into the river. In deforested areas, there are fewer trees to intercept rainfall and fewer roots to help water infiltrate into the soil. This means rainfall reaches the river more quickly. A shorter lag time is dangerous because the river rises faster after rainfall. This gives people less warning and makes flash flooding more likely. So the correct explanation is, human changes speed up water movement, making lag time shorter and flood risk higher. The correct answer is B. Human changes speed up water movement, making the lag time shorter and the flood risk higher. This is one of the most important ideas in the whole lesson. When answering GCSE questions about flooding, try to include this chain of reasoning. Urbanization or deforestation reduces infiltration and increases surface runoff. This means water reaches the river more quickly. As a result, lag time becomes shorter and peak discharge becomes higher. This increases the risk of flooding. That is a strong explanation because it links the cause to the process and then to the outcome. Now that we understand the causes of flooding, let's look at the impacts. First, we will focus on socioeconomic impacts. Social impacts are effects on people and communities. Economic impacts are effects linked to money, jobs, businesses, and infrastructure. Flooding can have serious social impacts. People may be forced to leave their homes. This is called displacement. Some people may need to stay with relatives, in temporary accommodation, or in emergency shelters. Floods can also destroy possessions. Furniture, photographs, clothes, electrical items, and important documents may be damaged or lost. For many people, the emotional impact can be just as serious as the financial cost. There can also be trauma and stress. Flooding can be frightening, especially if it happens quickly or at night. After the flood, people may face months of cleaning, repairs, and uncertainty. Now let's think about economic impacts. Floods can damage homes, roads, bridges, railways, schools, hospitals, shops, and power supplies. Repairing this infrastructure can be extremely expensive. Businesses may be forced to close temporarily or permanently. If shops, factories, or offices are flooded, they may lose stock, equipment, and income. Workers may also lose wages if they cannot get to work. Insurance costs can rise after major floods. In some high-risk areas, people may struggle to get affordable insurance at all. A good example is the 2015 Boxing Day floods in northern England, which cost the UK around £5 billion. So flooding affects far more than the river itself. It disrupts people's homes, health, income, transport, education, and sense of security. Flooding also has environmental impacts. One major environmental impact is habitat destruction. When floodwater moves quickly across the landscape, it can destroy nests, burrows, and vegetation. Animals may be displaced, injured, or killed. Fish can be swept out of the river channel and left in isolated pools when the water level falls. Another impact is pollution. Floodwater does not only carry rainwater. It can pick up sewage, oil, chemicals, litter, pesticides, and fertilizers. These pollutants may come from roads, farms, factories, drains, and homes. When polluted floodwater spreads across land or enters rivers, it can harm wildlife and contaminate ecosystems. It can reduce water quality and damage plant and animal life. However, it is important to remember that floods are not always entirely negative for the environment. Natural flooding can deposit alluvium, which is rich, fertile sediment. This can improve soil fertility on floodplains. Flooding can also help recharge groundwater stores, which may be useful during drier periods. So, the environmental impacts of floods can be both negative and positive. The important thing is to distinguish between natural flood processes and damaging flood events made worse by human activity. Natural floodplains are meant to flood. Problems become much worse when pollution, buildings, and infrastructure are placed in areas at risk. Now we are going to think more deeply. Here's the question. Which do you believe is the more significant cause of modern flooding in the UK? Extreme weather caused by climate change, or the way we build over our natural floodplains? This is an evaluation question. That means there is not just one simple answer. You need to weigh up both sides and support your opinion. Let's think about climate change first. Climate change can increase the risk of extreme weather. Warmer air can hold more moisture, which can lead to heavier rainfall events. If storms become more intense, rivers may be overwhelmed more often. So one argument is that even well-designed drainage systems and flood defenses may struggle if rainfall becomes more extreme. Now let's think about building on floodplains. Floodplains are naturally designed to flood. They give rivers space to spread out when discharge is high. But if we build houses, roads, shops, and businesses on floodplains, we place people and property directly in areas of risk. Urban development also creates impermeable surfaces. This increases surface runoff and can send water into rivers more quickly. So another argument is that flooding becomes more damaging because we have built in places where rivers naturally need space. A strong answer might say that both factors matter, but they work in different ways. Climate change may increase the frequency and intensity of heavy rainfall. Building on floodplains increases people's exposure and vulnerability to flooding. In other words, climate change may increase the hazard, while poor land use planning increases the risk to people. You might have said that extreme weather is the more significant cause because intense rainfall can overwhelm rivers and drainage systems, even in places with good planning. That is a valid argument. You might also have said that urbanization is more significant because building on floodplains removes natural drainage and puts people directly in harm's way. That is also a valid argument. You might have argued that building over natural floodplains denies rivers the space they need to expand during high-flow events. Again, that is a strong geographical point. You might also have linked climate change to the idea that so-called 1-in-100-year floods may happen more frequently in the future. The best answers will not treat this as either climate change or urbanization. Instead, they will explain how these factors interact. For example, climate change may increase the amount and intensity of rainfall, but urbanization and building on floodplains make the impacts worse because water reaches rivers faster and more people are located in high-risk areas. That kind of answer shows evaluation, balance, and geographical understanding. Let's finish by summarizing the key points from today's lesson. Flooding happens when the amount of water entering a river is greater than the river channel's capacity. The causes of flooding can be divided into physical causes and human causes. Physical causes include intense rainfall, prolonged rainfall, impermeable geology, steep relief, and saturated ground. Human causes include urbanization, impermeable surfaces, drainage systems, deforestation, and building on floodplains. A key concept is lag time. Lag time is the delay between peak rainfall and peak discharge. When lag time is short, the river responds quickly to rainfall and flood risk increases. Urbanization and deforestation usually shorten lag time because they increase surface runoff and reduce infiltration. Flooding has serious socioeconomic impacts. It can damage homes, force people to leave, disrupt transport, close businesses, increase insurance costs, and cause emotional stress. Flooding also has environmental impacts. It can destroy habitats and spread pollution, but it can also deposit fertile alluvium and recharge groundwater. The biggest takeaway is this: flooding is not just a natural event. It is shaped by the way humans use and manage the land. To understand flood risk properly, we need to look at both the physical processes and the human decisions that make flooding more or less dangerous. Before we wrap up, I want to remind you to like this video if you found it helpful and subscribe to our channel for more content like this. Your support really helps us continue creating valuable presentations. Thanks for watching.